to another video. Continuing on with the static analysis that I showed you in the last video. You might see that I've made a few commits, so I've got 14 more things, basically adding a bunch more opcodes and stuff. And I've also kind of named the tool ASM check. I don't know, I thought it seemed like a decent one. And I've also got a cool feature that, so say if we look at the file that we were looking at yesterday, it's got the cool feature that if we I'll just kill that over there, boom, and do that. So it's got this like rebuild self type thing, and the very first thing it does is check whether the binary is older than the source file. And so if we do that and run it, it will actually recompile it. So it recompiled it and then reran the new one. So that's kind of a cool thing. Now I've also, if we look at the status, I've got quite a lot of stuff. I might just have a look at what is there. So there was a few more things that I didn't add just before I left before. There was stuff on there. Yeah, so I may as well I'll step through all that. So all of this stuff will add in. And this is kind of like the main thing. So we can like add to the stack. That's kind of a useful thing. But yeah, well, I'll show you what this does. Add more ops and to add sub USB. And then we'll push that all up as well. So what I might do is, now that, gosh, that's quite slow. I was thinking about that. Right, so what I might do now is if we look at this, so now we have a bunch of stuff. I might just hide that in the stash, just to kind of show what it does. And if we go, this one here, and only get the ASM because so there's a few features missing from the library. In fact, like, we'll have a quick look through what it does. So stuff that's changed since it was last on video is it does this rebuild self. That's about the same. The list of opcodes is a bit longer, so we've got a few things. And then we've got a couple of helper functions, basically whether it's a cmove question mark thing. So that's something like you can go like test eax, and then cmove ecx. So what they will do is if eax is 0 in this case, it will put ECX into EBX, but if EX is not 0, then it won't. And that's done just through the kind of flag, so you can set this to be like CMP EAX and 5 or something, and say if it is greater than equal to 5, then set ECX into EBX. So the idea of having separate kind of separating out that logic is because they can have two different branches in respect to whether a register is valid or not. So we got that, and currently we've just got move E and GE, but we can add more there, and we've also got another function for if it's a jump code, and again everything is basically not except for this list, which is not, and I'm sure I'll add like a few more, and then it'll be more like this format, one per line. Still had this last time. I think I've added in this C call, which is a macro, but we don't handle macros just yet. And same thing. So it's kind of funny, like 400 lines in, and all we've done is kind of define a bunch of operators. But that's alright. Yeah, so that's all the same. So some of this can probably get split out into different files, but that's right. The parse line is mostly the same, except for in this kind of else branch. Here we... so this is basically if we haven't been able to set an opcode from basically what is there. So it's not a label and it's not an opcode, then it must be something different. So here we do like a kind of hacky thing, checking for equals or the equal. I think it's a macro, but we kind of treat it as an opcode. And then there's also this times thing, which to do actually repeat the opcode. So the times is where you can go something like times 5 dB 0, and they'll basically kind of allocate 5 bytes, but you can also do, I don't know, stuff like this, like add ESP 4, so you could do that. The way I do it is, the way I use it is mainly just like this, to kind of allocate a bunch of space. So this 5 I would have some sort of a cap macro constant, and then do that. And this is probably where the macros are going to get handled, but if it can't do anything, it will fall back to just failing. And I found that there was also a bug that sometimes it would get to this point here, and it hasn't actually found an opcode for it was kind of for single line things, so like CLI wasn't getting picked up because it wasn't a valid opcode at the time, but nothing was complaining about it, and it just kind of skipped the line because there was basically a statement with nothing set. So now we see whether the line is empty, and if the line is empty, and if the line isn't empty, but the statement that we've generated is basically empty, then we kind of assert and say we can parse it. The register state we've kind of kept the same, and yeah, I've kind of done a small like helper method to this bit will probably change. So this is say if you might have move EBX from say EAX, which is moving from the memory address that EAX is pointing to. So the way this works is it basically strips off the brackets, because all the check it's doing at the moment is whether EAX is defined. In the future I'll probably have it so it will be able to see whether EAX is defined, and it's also kind of a pointer value, but that's kind of like more a type system type thing, but for now I just kind of strip it from that. And I also kind of do the smaller codes, so like the low and the high bit and the 16-bit for all of them, except for ESI and EDI only have they don't have the high byte of the low 16, and I also on purpose don't look at the stack pointer or the base pointer, because we kind of deal with them separately. Now I've kind of made a little helper basically to see whether a register is defined or not, and it's kind of got a hacky thing that if we're trying to look up something that isn't actually a register, so it's not in the regs, then we'll say it is defined. But again, in the future, we'll probably break that out and then see whether it's a valid label or because if it's a label, then it is probably pointing to some portion of memory, and if it's not a symbol, then if it's just a constant, then it's probably pointing to a value. So they'll probably get revisited when I work on those sorts of types. And this one, so this is kind of like a helper to go through all the operands of the statement, and we can include the first one in this list, or sometimes we don't want to, because sometimes it might be the destination, so we don't actually care if it's defined at that point because it's going to become defined after this point. But in some operations, like for example, or say if we do or EAX and EBX, this EAX is both the source and a destination, so we need to make sure that it is valid or defined, which is what we're doing. So the simulate is pretty similar to where it was. It's just got a few more things. So clean up the ret and stuff. There's probably some more stuff we can clean up, but it does the trick for now. And the iret checks that all of the registers are the same, but it kind of skips over the stack pointer and the base pointer, but it also asserts that the stack is empty. Basically, if you're calling an interrupt, you don't want any of the things to change, so that's the calling convention of an interrupt handler. And then there's other functions like lodsb needs a valid ESI, but then it sets EAX, and then stosb it requires a valid EAX and EDI, and doesn't set anything to be valid afterwards. So kind of lots of stuff like that. And you might have seen this in the just last commit. So if we're doing, so these commands are all pretty similar. They're basically all two operand things where it's kind of a source and a dest, but the first operand is kind of a source and a dest, if that makes sense. So we'll see that we set the true there, which basically means check that first one as well. I wonder if you can do something like include first. I think that's kind of what I want, and I think I also want to open up a new window osdev, and if we just run asm check, see it rebuilds it. So it's kind of based off another YouTuber I watch. He's got a project which is like called no build, and the general gist is you can use whatever language you are as your build command, build tool, rather than having like make or something like that. And one of the functions in it is basically to rebuild yourself. So you call a binary and it rebuilds itself if it needs to. So this doesn't do what I wanted. Can we do something like that? I don't know. Right. I'd kind of like it to do that, but that's alright. Back to this. And so here we see that all those conditional moves, they kind of just act as if they should do it to start with. And then further on there's like a branch mechanism for that, and you'll see that we also don't really treat whether different parts of a register, like different, like AL, we don't check whether that's specifically defined or not. We just kind of look up EAX. So this, some of these opcodes, I've kind of just hard coded them to how I use them in my operating system project, but there are other ways you can call it, like when you go out, I kind of do out and you have like a address and then you have AL, but you can have multiple different types. 86 out, this one, output to port. So we can have like kind of different ones. It all comes from EAX though, I suppose, but there's one form that it'll take a DX rather than immediate, but the way I use I do actually use that out DX. So I probably should. Though that gets checked with. It doesn't actually check. If we did something like this. I think that will do the trick, but who knows? That might break everything. So basically a whole bunch of stuff, and like I have special care for the mull instruction, which sets two registers as defined afterwards. So there's a bunch of stuff, and some of it was here before, some of it wasn't. There's probably still stuff we could clean up, and when we push A, we push all of the regs on, and when we pop A, we pop them all off. Theoretically, we could pop them off one by one, except the fact that we kind of don't care about SP and EBP. We might fail. And I kind of just like hard coded in like flags for when we're pushing the flags, and there's also the branch where it's not a register, so we're kind of like pushing data. So at some point when we do the call, we could potentially detect whether the arguments that we're passing to the function are legit, but for now we don't bother, and I think the tool works alright for how it goes at the moment. So here we print out a bunch of stuff. I think this might be new. So our visitor now has like a list of states for each statement, because I realised you can reach the same point multiple times, but the states might be different, but that's not a error. When the states are the same, that means you can stop. But when the states are different, you should keep going and see basically whether you get to the end. And it shouldn't trigger endless loops, I think, but I don't know, I could potentially practice with that a bit more. It hasn't in any of my code. So we kind of added the state to the visited set before we do anything, and then before we simulate it, we see whether it's the C move, and if it is, we kind of just add a branch for the next instruction with the current state, so basically nothing happened, and then we simulate it, and in the simulate C move conditional moves will always trigger. And then if it's a jump instruction, we kind of branch to whatever branch we're jumping to. Yeah, I think I want to do like a to-do call to dot functions private dot functions. So that's something that came up during my testing was sometimes you have, well, for example, in source lib stdio, which is one of the first things we have a call. We have this kind of like inner function called padding because it's used a few places. Yeah, and this currently is kind of like a function all in one, but I only really did it just so you couldn't do a jump because you need to know where to jump back to. So I kind of just did a call, which, yeah, potentially, I wonder if you can just kind of push the return pointer. But yeah, anyway, this isn't getting checked with the current thing, which, I don't know, looking at it, it looks like it probably is alright. Also, we don't really check whether things... We don't check everything, but we check a fair amount. So yeah, I guess now that I've kind of shown that off, I'll do this list again and kind of show some of the stuff it finds. So it doesn't do include, so this file, it literally finds nothing because if we look at it, it's basically just including all of these files. We'll deal with includes at some point. But yeah, you would think that there will be some bugs, and there probably are. And I have actually fixed them all, so what I might do is tools asm check and turn off the parents. Just because that makes the a bit better. Lib unisted. Yeah, so that's fine. So there's some that I couldn't do, like pthread, because well, potentially I could, but it uses like some weird stuff. But yeah, if we just keep going up, there's like a bunch of stuff, and this checker isn't finding anything bad, which who knows, is that a good thing or a bad thing? But yeah, now here we get something where it did have a panic. So in this tick handler, EBX is altered during the function. So if we go back to here and source drivers pit tick handler. So if we go to this, so EBX is altered during the function. So we can see that it is indeed, there is an EBX that is altered, but there's no like push or pop. So can I do like, no, I can't do that. But if I look at, can we do that? Nah, we can't. Alright, we'll just have to do that. Yeah, so my fix to it was basically change the EBX to ECX because that's fine. So may as well just do that again. so that shouldn't change anything, and it should still sit with everything we do. So if we run it again, it now has another thing. Branch to global label panic should use call. So what's happening here is we're just doing jump to panic, which is something that I was doing early days, but I think a call to panic makes more sense. So we do that, and now it's all good. So this tool is kind of good that we can just find stuff. And here we've got another one. So if we look at this, so debug add function. So in this, it says pot reg edi does not match stack with esi. The wording could be better, but if we so we see here at the start we push ebx then esi, and if we go down to the return we see we pop edi then esi. So edi we never actually did, so it should be something like that, which I mean we can no edi, yeah, so if we search for edi there's just none in this entire file, so that was just literally a bug. So theoretically, yeah, so we would have just jumbled up the functions there, which isn't really great, and now we do it again and it's all good, all fine and dandy. Music's all good. Music is all good. This one I think we don't do. Yeah, so a no-opcode struct. Yeah, I might just hide that for now. A no-opcode struct. So we don't deal with structures at all, and I'm not sure whether we will anytime soon, but we might. I mean, they're kind of like a macro, but a lot of the stuff we probably wouldn't know how to parse because we're parsing line by line, so we'd need to know at this point we're inside of a function, inside of the structure, and at virtual we'll kind of need to know that we're inside a virtual block, and that's what you do. But for now the options are either basically pulling this out into a kind of include file, which is potential to do, or the other option is kind of just skipping that, because like we haven't got full coverage of everything, so I think it's alright to skip stuff if we can't do it, so we don't want to do that. We want to check that file. So here we we couldn't parse line halt, which I don't know. So I fixed this in the other one. Do we say what line it is? Nah, we don't. But I guess we can search for halt. The way I fixed it was just go ret. Actually no, I think it was jump to return, which it shouldn't happen because it's unreachable. But Panic should be doing that stuff, which if we look at it, where do we even define it? I think it's boot 32, Panic. Yeah, so if we look at Panic, yeah, so it does this halt, falls through to it. So we can kind of ignore it here. Theoretically, we could just have nothing, but having a jump to return is good. We could do ret, but I like the jump to return because, say if we do this ret and run it again, it'll say EBX is altered during function, because theoretically at this point here, EBX is being changed, and there's also something on the stack with EBX. So if we just jump to return. The static analysis flow will jump to return, which is down here, and it'll pop the EBX, which has the good side effect of if panic doesn't actually panic for some reason, then yeah, we keep going as normal. So VGA text. So this one, oh, that wasn't in my earlier thing. VGA. No, we want to go to drivers. VGA text. Yeah, I think I just did DB0. And yeah, how I did that is all of these we don't actually use, but they're kind of hard coded in the tests. So what I'll do is kind of just return early, so it doesn't do anything, and this should be a string, which we could do a ret as well, but yeah, it was kind of just failing on this, well, like anywhere up here, and it keeps on going, and it's just like, how do we deal with that command? Because at the moment we don't really deal with it, which at some point we probably should. But yeah, we can see that we're getting reasonably high up this list of stuff that we have. std live, yeah. So that's got another struct, so I'll just skip it. String, that sounds good. So this, I did a similar thing. Yeah, so this SDR copy, I basically just put it down there, because these EQs work no matter what, but because we can't really easily define it, because say if we look at what arg1 actually is, it's basically, well, arg1 isn't even that, that's arg1 offset. So arg1 is that which requires doing that. So it's kind of like, and it requires loading this include file and working out what to do, and this is like macros, so we kind of just slip it down, and then all good after that. What is next? Read key, brand new library, all good, no changes needed. So stdio, so this one was an old one. ECX doesn't match ECX, and an old printf. Yeah, so this one, yeah, I kind of need better printing to say what line it came from, which is in the statement. But yeah, I'll also print out the stack, because I think that was also kind of handy. Yeah, so here we can see that it's inputs with precision. So at this point here, we do this pop. So this pop is coming from quite a way away. So this was one of the first libraries I wrote. But yeah, we actually, like, in various places we do this, like, push EAX here, and that's roughly why it's saying it doesn't match EAX. But yeah, we push an EAX there. We also do it in other places as well. Yeah, this puts, so we push it there, then jump to puts with length. And was there another place? I thought there was a third. this one we like pushed a few things, but no, I think it's alright. Oh yeah, there was this place as well. Yeah, so we push a double of whatever the memory address of EBX is. Now, this is where there's a bit of a problem. So I can fix that issue. It's kind of an issue that keeps on giving, I guess. So say if we push EAX, so here if we like mod ECX EAX and push ECX instead, here we get a different kind of error. It's the same error, but it's in a different place. And we can do the same thing here, EAX and ECX. Yeah, and so now pop reg does not match stack with EBX. So that came from this one. Nope. Push D. Yeah, this one here. So what we can do is just and we can actually not do the push D anymore. Yeah, so here is where we have more issues. So here pop rig. So this is like way at the bottom now. So we fixed all those issues, but when we look at this, we're popping EBX. So I don't know if we pop ECX first. That's a bug. I'm not going to keep it. But if we do that, yeah, I suppose that breaks on one path. So the issue here is, which you can kind of see it in this backtrace, but not like super great. But the gist is that we go to the error state while we've still got this ECX on the stack. This was done when I wasn't that great at coding, but we can see like in here, well, basically it all comes from puts with length. So at this point here, we could go pop ECX and then push ECX, and that would kind of move the problem down, because then down here we also have a conditional, and this was where I saw that cool padding, and I'm like, I wonder if it does it. It does not. We don't test that at all. But yeah, there's another conditional there that we kind of need to. Well, I suppose it's just the ones to the error. Yeah. Right. So that is. In fact, that might do the trick. Nah, it doesn't do the trick. That might do the trick. It doesn't really matter that whether it's before or not. Yeah, cool. Yeah, so it was only around this error handling that we basically need to keep it on there, and all these ones kind of keeping it in with this. Though theoretically the no, because we push it and then we pop it back later. Yeah, so that's alright. I'm happy with that, I guess. Yeah, so if we do that, and I don't know, we go up to STGO, drivers PS2. So this kind of do to do. That's right. We source drivers PS2 keyboard. Extern panic better way to do that, I think. And jump.return, do you exist? We'll find out. Cool. And so this tells us that EBX was altered during the function, but we also have EBX on the stack with the initial value. So if we actually look up at this, we push EBX and so it's not in that function, it's PS2 handler. So if we look up PS2 handler, so PS2 handler, we push EBX, and then when we look down at return, we don't actually pop it. So there's another bug that it legit helped us fix. Shell was that one? We can add that in, but I'll just do this as well. Yeah, so those two we can get away with that. So I don't know. I'll kind of fix all these, I guess. ASM check, fix bugs found by ASM check. That's probably a good thing. And at this point, yeah, we'll do some live coding. How long we've done? Yeah, that's probably a good thing. So I'll kind of show the process of adding in a new thing. So std, we've got str, we need std. Probably means we need cld, but it will tell us. Yeah, and what I might do is while I notify not sure why that's not liking it. Tools ASM check, do ASM check source lib term.asm and none. Yeah, cool. So that does that. So now every time we redo it, it will basically rerun the thing, which it will rebuild it if necessary and do that, just so we can kind of see the live updates. So what we need to do is there's a few different places that we need to kind of add in the stuff, and Rust will hopefully actually tell you. I mean, any language can be set up to do this, but yeah. So now it knows what std is, but it doesn't know what cld is. So that's set the direction bit and clear the direction bit. So let's do cld and cld there. Alright, and here we're saying it doesn't exist for std, so what we'll do is doesn't know how to print it, and I'll just do it for cld as well. When we do that, yeah, so now it doesn't know whether those two commands are cmove. So what we can do is just add them in, sti, yep. Now I know that it will also be here, so we can also say it's not a jump instruction. So now it goes all the way down to jeepers, over 1,000 lines, but yeah, now it goes to here and simulate, and it's like, I don't know what to do with this std cld, and what I'm gonna do is put it up here with a to-do actually. Set flags, because it is very similar to CLI. So CLD or some opcode std, that one, and we'll do nothing with it because it doesn't really change anything. Cool. So that basically did it and processed that whole file. So that was on term. What about shell? Right. So shell we can't easily do because yeah, we really should have better errors that shows what line of this file it is. But IOSP underscore P, yeah. So here we, yeah, it doesn't know what this is, which it's defined in source. Yeah, lib includes in term iOS. That will do. Now, what is the other one? And this one. So term iOSP. No, where is this defined? Yeah, grep term iOSP. It's just a name. Yeah, it's just equal to that. Goodness. I think I need to go into shell. Yeah. I just wonder where that kind of comes from. What syntax is that? Yeah, because we don't really say what it is. Yeah. I mean, that runs, right? Resource drive BPS to keyboard panic. Yeah, so it still runs. Well, it still builds. Looks like it still runs. We can still do stuff. We could run a hopeful test. Kind of looks like it's doing stuff, but then breaks there. Term move 0 0. Resize or 8025, and then run the test. Yeah, that looks better. The scroll wasn't quite working, but yeah, that looks like it passed most of the tests, so we'll just kill it there. And debug still looks good. Yeah, so we didn't break anything, but yeah, just wondering what kind of instruction that is. In fact, did it in this commit. So I include that where in the shell. Yep. Goodness, I am at a loss. Undo whatever we did there. And if we it's like it's a valid instruction indeed. What makes it a valid instruction? So I guess it's, I mean, it's like when it's a, but yeah, then it's not really done there. What if we do like that? Well, that's still like, yeah, I'm just thinking that's what it was defined to at some point, but we like never set up anything for it. I mean, it's meant to be that lib includes term iOS. Can we just phasm view? Yeah, so that like broke this. Weird. What's like? Do we just do that? Yeah, it seems like that. I don't know, so that is just defined like that. Yeah, I might need to read the things on that a bit more. The docs. But yeah, I guess for now. What if we I feel like it doesn't even need to be there. It can be time size of dot term iOS db0. I think that would be a better way of doing it. And that still works for what it is. And now if we run async check. Right, yeah, so that yep, and that can kind of just be a cheap way of doing it. File. Oh yeah, we definitely don't know what file is, but we can make it kind of a. We have like include there. I guess I'll throw in a file. Back to that. Now it will. Use of undefined reg edx. Cool. So that's like telling us bugs. Bugs are always good to do. So that is 725. Do we still have that file open? No, but if we source util show 725, we can look at this. It's off by 1. That's alright. So it reckons edx is. So this is one of those things where we're calling this private function again, which I think, it's up here. But in doing that, it kind of, it kind of forgets what we are, so it thinks that edx has been blown away because this function might blow it away, which it doesn't, but I guess that's, so I mean we can do push edx and pop edx to kind of get around that. So now it can play into the different step, 727, push edx, pop edx, it's the same issue. 749, what are we saying? EDX is still 749. EDX and pop EDX. So you can see we already did one for EDI, but that's because we knew that EDI actually did get altered here, which is kind of like it shouldn't, but that's alright. Cool. So we do a jump to panic. instead. Use one von reg edx again. Right, so sim52. So edx was undefined at this point here. So who calls edx only gets set at that point there. So this does seem like a bug. What even is this doing? This is printf, of course it is. So we'll basically go through, we'll go into this sort of loop, we'll work out what it is. edx should be ESI at that point there, but there's probably a call that will clear it in a way, but yeah, we'll go into parts format, we'll work out it's a char type, so we go here, so ebx gets shifted into edx, but then we call this next arg. So I think if we do that, that might do the trick. And char to long error. So char to long error takes that and also says what we got, which was EDI, which EDI is the next argument, yeah. So what I guess we could do is, so that would be the fix, I guess. So I still thinks, but it's 740. Yeah, EDX, EDX 742. So that's well, you definitely should be set. Could happen up there. Which I'm seeing a pattern, which I might, because we store it in EBX, so I think what we'll do is just use EBX. just do a run on that just to printf like on that. Alright, it's an error on the D having that, but yeah, errors on that. Printf. We can't get more out of it, but yeah, printf. So it doesn't have as much. What can it do? It can all the integer type things and string type, and yeah, so we could do like a hex or an octal, just as a quick test. Printf. So hex of 16 should be 10. Octal of 9 should be 11. Yeah. And did I see a T in there as well? I know 7 can be like. No, we didn't have a T. That was the other one. Cool. Yeah, so this is all looking good. Might just look at what we kind of fixed. Yeah, so we missing format error string. Yeah, so let's just test that. Printf without anything. Printf. When does that get called? Right, so we'll put that in source utils shell missing format. Yes, so that is when we do just this printf and just a single thing. Yeah, so that is printing a null, which I wonder what it was printing before. So what was that printing before? Yeah, so it printed the character that we were stash pop. So missing format error. We probably want to do ESI there, so that's what EDX is up here, and then we go to pass format. So I think this could be ESI maybe. I kind of see. Wow, there's no calls there, so yeah, I think push EDX and pop EDX. that happy. Printf, do that. Now it shows that, and asm check on that. Still all good. Right, we'll go back to adding all things that we changed. So yeah, we keep that one. Invalid format error. Right, so source util shell invalid format error. So I think invalid format error is in the same issue that if we go printf and like, I don't know, not deq, it prints null. We don't want it to print null. So invalid format error. So here we'll push edx and pop edx and call that with edx. So I think some strings, so we'll go no for that. We'll also check whether that's doing a printf. Yeah, printf. And that shows a missing argument, which I think is probably what we want to do. Missing argument error, because that was whatever. Yeah, we basically set ebx to be that. Yep. So we will keep that one and char too long error. So here if we go printf c and yeah, so it knows that's where it is, and that's the string that we're printing. Yep, cool, I'm happy with that. We added a couple of things. Asm check more fixes for issues found with asm check. Cool. Now this is pretty good. So like, I don't know, I've fixed a bunch of bugs. Origin, that one there. Yeah, so we've made a bunch of changes in a few different libraries. They're not like drastic. There's a few in that, but yeah, all of those kind of bugs were likely bugs that would have come up at some point in the future, which would have just been annoying. So I think it was worthwhile running this kind of static analyzer type thing, and it's starting to rain. Yeah, so we're all still good there. So yeah, where are we at? We're basically, we couldn't do a few things like yeah, I think pthread, because it used weird things. Oh, there's some thunder. Was it iOS? Nah, that was all good. But yeah, there were other ones that we couldn't use because of structs. That one had some structs. What did I put in that test.asm? Yeah, that was just testing asm check test.asm. Yeah, so we're using ebx when we can't be sure whether ebx was set in this one here, which it would have, but we don't know if it would have. But say if we do set it to something before, then this will pass. So yeah, this is kind of cool. But yeah, I guess I don't actually need that file anymore. Oh yeah, I wanted that in that commit. push that up. Probably can't do it there, but I can do it there. And yeah, I think that's probably enough for this video. I'm also hungry and need to make some dinner, so I'll do that after this. But yeah, hopefully this is of interest to some people, and I'll probably work on it at some other point. I'll probably take a break on it and get back to the actual operating system stuff now that I've kind of made a proof of concept. And yeah, it was kind of just a way to learn a bit of Rust. But yeah, if I work on it again, I'll do another little video. So I guess what we could do is if we could check out main, and we can actually merge in that static analysis, and that's just part of that now. So that is that. Because yeah, it did fix like a bunch of issues that potentially branch must do static analysis. Yeah, push origin, nothing to static analysis. I think there was a command I could have done to do it in that step, but this one's alright. So yeah, all that static analysis stuff is just in main now, and I should just have that memory one, and I might try and merge in origin main, just to cool. So we still can do that. Potentially rebasing. I don't know, it's hard to know. I'm trying a different way of doing things. But I like having different branches on the different projects, but yeah, this one was getting all the memory. Look at that, we know where memory is. But yeah, cool, that's that. And yeah, let me know if you like this, and tune in next time for whatever crazy stuff I'm up to then. Have a good evening wherever you are, or morning or day or whatevs. See ya.